Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll show the new option in multi-axis machining for multi-blade machining as shown on our screen. If we take a look at the part that we have on the screen, you can see the multi-bladed part that has to be machined. Previously, to machine a part like this, there were a lot of parameters that you had to take into account for gouging, for angle control. All this had to be determined manually. What we've done in the multi-blade machining option is to actually make this as automated as possible, allowing you to choose easily exactly what you need to do without worrying about many of the parameters. Let's go into our first operation that I've created here. And if we open it up, you'll see we'll be doing multi-blade machining. And we have the option over here of roughing, blade finishing, hub finishing, and fillet finishing. We'll start with the roughing of the part itself. When you go into geometry, you can see by touching each area exactly what you need to choose. For example, the first is asking for the blades, splitters, and fillets. And in this particular case, I chose exactly that, my blades and the fillets, including over here. If I were to go into my hub, you can see I have my hub, which is this area over here, the floor over there. And it also requires me just to choose the shroud. The shroud being the actual top of the blade as shown over here. The option that we have on top is the strategy of offset between hub and shroud. Among others, we also have offset from hub or offset from shroud. Most often used, however, is the offset between hub and shroud. Now, let's go into our tool. The tool in this particular case, I'll be using a tapered mill tool. The reason for using a tapered mill tool is because it's a very sturdy tool. It's used very often in parts like this, where you can have a small diameter at the bottom, but still have a strong tool up towards the top. So this is a much stronger tool to use, and we do support using tools of this type. Now let's go immediately to our toolpath parameters. All we have to do over here is determine the maximum number of layers as shown over here and the slices as shown over here. I do not have to do anything in the tool axis control or my links or even gouge check. Now let's take a look at the machine simulation, and you'll see that the tool is actually working exactly in that area itself. As I zoom in to the blade itself, you can see exactly how it's working. And let's just go a little faster. And you can see that it's actually working exactly the way I want it. Roughing it out from the top and then going down to its next step until it completely finishes the part itself. Let's stop it over here so we can see what was done up until this point. And as you can see, it's actually working around this entire area. Now, if I want to do this on the entire part, all I have to do is go into roughing and more and go directly to rotation. And rotation is all very simple. It's just pick the number of segments. In this particular case, I want to have all 5 segments. There are 5 segments on the part itself. And I can either machine it by determining the numbers of segments I want to do or do all of the segments. I can also do each segment individually or do it by layers across the part or by slices along the part itself. You can see also on the side the diagrams that are chosen every single time I change the sort option. And this, by the way, the diagrams also change in every single one of our fields over here. Let's change the sort by to layers, for example, then calculate and run my simulation. You'll see that the tool will go down, work at the first level as shown over here, and then when it finishes that, before going either further down into the part, it'll actually now turn and do the next segment, finishing each layer over there. Once it finishes that particular segment, then it'll go to the next one and to the next one When it goes back to the first one, then it'll go to the next step as I've determined that's the way I want to work on this particular part. Let's stop the simulation for a moment, and you can actually see that each segment is being machined out around the part itself. Now, in our next operation, we've used the same option of multi-blade machining, but this time we'll be doing blade finishing, working on the blades itself, as shown over here in the diagram. The geometry, just as before, we have our blade splitters and fillets, as shown over here, working on this particular blade over there, our hub, and of course we have our shroud, which is the top surface over there. The tool again will be my tapered mill, and if I go into my toolpath parameters, again we have our layers determined by either by the maximum number of cuts or by a specific distance on the part itself every single time you want to go down. So you can do it by either way, either by distance or by the number of step downs you want to do. Running my simulation, you see that the tool will actually go down on that one blade exactly 10 times all the way down to the bottom. And again, we also have the option of going to roughing and more, and again doing rotation according to the amount of segments, and so on and so forth. Now, our next operation is again the exact same thing, but this time, since it's a different blade, we have a different operation for that particular blade. Now, in our next operation, we have the option of fillet finishing. If I go into my geometry, you see we have our geometry, which includes the fillet at the very bottom. And of course, we have the hub determining the actual floor of the part itself. If I go into my tools, again, I'll be using the taper mill. And if I go into my toolpath parameters, we have the option of choosing on the blade side where to work, either by the tool diameter, by the big tool diameter, or other options are shown over here by number of cuts, or by same as hub side, which is over here. In this particular case, I'm just going to show it as by the big tool number. In this particular case, I've chosen my big tool diameter as 8 millimeters. I can also have an overlap if needed. And we also have the hub side, how much of a cut do I want to have on the hub side itself, which can be determined by the number of cuts, just as we had on the blade side. Same options we had over there. Let's run a simulation, and you'll see that in this particular case, it's working exactly in this area over here, just around that particular radius over there. Now the final operation that I have over here is for actually finishing the floor. So if I were to go into the operation itself, you'll see that I've used the option of hub finishing, finishing the actual floor, which is the hub. And you can see that on the diagram over here. The geometry, just as before, we have our blades and we have our hub separately. We have our tools. In this particular case, I use a ball and mill. And if I go into my toolpath parameters, all we have is over here is just determining either the number of steps or the actual distance between each step itself. Taking a quick look at the simulation, you'll see that the tool will actually go in, work on each area exactly the way it's supposed to around the blade, finishing off the hub up until the very end. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.